Welcome to Data Hurdles, a weekly podcast where we explore the impacts data and technology have on our day-to-day lives. My name is Michael Burke.
And I'm Chris Detzel. All right, welcome to another Data Hurdles. I'm Chris Detzel and
I'm Michael Burke.
Michael Burke, how are you?
Doing well today, Chris. Beautiful day here. We had a little rain come in, but got this project I'm working on. It's totally outside of Data Hurdles right now, where I'm doing some construction in my house, which is really exciting, building a pantry. So my off hours are completely occupied on this, hammering wood and making sure it's straight and square. And of course, like me being a data guy, I'm trying to do way too much analysis on what we're doing. My dad's a contractor for this. So work on this project. He's like, just move, continue working. And I'm thinking about squareness and all these things to a degree that doesn't need to be thought of. So that's my day outside of work. Yeah.
Well, it's always good to hear what's going on a little bit outside of work. And so I was telling you a little bit earlier that my wife and I are going out to Big Sur. So we live in Dallas, Texas, but she's running another marathon out there. She ran Boston a couple weeks ago, but now we are off tomorrow, which will be a Friday to a Monday for her to run another marathon. But I get to watch and hang out. So yeah.
Very cool. Are we targeting a specific time for this one or?
No, I think on that one, she just, it was kind of a special thing. It was called Boston to Big Sur.
Awesome.
And she was offered to go, and so she was like, "Yeah, I want to do it. It's kind of like a bucket list." And so she did that. So yeah, I mean, it's just a fun marathon, if you can call it that.
Very cool.
So, well.
Oh wait! This is the Big Sur run. I think I've heard about this one before. Yeah. It's pretty wild, right? Is this that wild race? Yeah.
Well, it's hilly and it's beautiful, but it's really tough, and so, so she's not looking at a time or anything like that, but yeah, it's pretty well known, I guess, within the marathon peeps, stuff like
that. Very cool.
So, yeah. But, well, we digress a little bit, but I think that's okay. I kind of like that. But today we're going to talk about entity resolution and more specifically around machine learning and large language models with entity resolution. What do you think?
Yeah, let's do it. I think it's an awesome topic right now. I mean, large language models are changing everything around us, and not to be another person on his soapbox talking about large language models, but really when you start to use these, which I hope most of the people on this call have used a large language model like ChatGPT or others,
Bard,
you start to see that there are areas of work where things are going to dramatically change, right, across the board. So I think that for the purpose of this talk, we're going to assume that you have a baseline understanding of large language models, and I'll give a really high-level overview and also entity resolution. But we can talk about both of those quickly. What are they? Entity resolution is really the process of identifying and linking different records and data points together that refer to the same thing, right? The same real world thing. It could be a person or an organization or a job or a profession or a medicine, right? But you're taking data from siloed sources and you're bringing it together and you're making sense of it, saying these two data points belong together and they represent one thing. And then machine learning, if we think about large language models like ChatGPT, they can greatly enhance this process, which has traditionally been built upon rules and very standard structured methodology to provide better accuracy, efficiency, and really allows organizations to reduce errors, save time, and gain valuable insights on their data that they wouldn't have otherwise been able to get through a rules-based system.
Yeah, that's really great. And I feel like you don't say Bard, so we're going to put Bard into that as well.
Yeah, we'll add Bard and Flan T5 and all these other models that are growing. ChatGPT is the one everybody's heard of.
Everybody. Yeah. We'll have to offline. You have to tell me a little bit more about the one you just mentioned that I've never heard of. But let's go to the next question, because I think getting to this is going to be extremely interesting. How do you supervised and unsupervised learning algorithms, we'll get a little deep here, differ in their approach to entity resolution, and what are some of the advantages and disadvantages of each?
Sure. Yeah. So let's just first, for everybody on the call, break down what is supervised versus unsupervised. Supervised learning algorithms require labeled data to learn, right? So think about, you're predicting the price of a house, right? You would need to know other houses' prices to be able to predict, and other variables to be able to predict the current price of a house or the forecasted price of a house. Versus unsupervised learning doesn't require any labeled data, and instead it learns through its experience, right? Which some would argue is also labeled, right? And uses clustering and similarity measures to kind of gauge how things belong together or how they are different, right? And so a good example of that would be like a classification model, where you're looking at the patterns of things that belong together and trying to kind of group them, based off of the different attributes that you're evaluating.
Okay. And did you mention any of the advantages or disadvantages of those?
Yeah, absolutely. So when you think of supervised learning, it is really focused around, you can get higher accuracy, right? You're providing trained sets of data, and if you have really well-trained high quality data, you're likely going to get really good high quality matching. And so but the challenge with that is that supervised learning takes a ton of time and energy and effort to label all those records, right? And so unsupervised learning is another approach that you don't need to have all of that data, but you can learn that data through either responding and interacting with a model, or through it making assumptions on its own. I think that if you look at things like Open AI Gym, OpenGym, I think is what it's called, is a really cool example where you can look at real life demos of unsupervised models and reinforcement models, and how these things learn over time, right, through different experiences.
Yeah, just one's more accurate, and then the other, but one's more accurate, one's less accurate, but one takes longer than the other, kind of thing. So
right,
do
and
you want
these are
speed better or more, or do you want? I mean, it's kind of a interesting thought there.
Yeah, and these are all kind of ambiguous terms that we're talking about right now. Really, accuracy, it depends on the quality of your data, right? But assuming that you had the same level of quality and you could invest the same or more labeled records for a supervised problem, you're likely going to have better accuracy, right?
Okay.
I'm sure there's going to be a bunch of data scientists like, I disagree, but it's a good discussion to have.
We could go deeper, but let's get through some of these questions because I do have some thoughts around that particular one. If I remember, I'm going to ask it later. How can large language models, or we can call them LLMs, maybe we won't, but how can they enhance the accuracy and efficiency of entity resolution, and what specific capabilities do they bring to the table?
Yeah, so I think this is really interesting. When you think of a large language model, right, and I've said this multiple times, so I feel a bit like a tape recorder, but it's trained off of a huge amount of information. It's trained off of the internet, right, in some circumstances, or a subsection of the internet. So when you take that to a problem like entity resolution, all of a sudden, all of these things that might be really hard to train a model on just with your data, like, for example, nicknames or abbreviations of like LLC, right, as in an organization name. A large language model has the context and understanding to understand that Mike and Michael belong together, or that company X Inc. is the same as company X Inc. Incorporated, blah, 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 right? So similar to the experience and the context that we have as people when we're evaluating records, it can get you closer to that understanding of saying, we've seen the relationships between these two types of data in the past because we've been trained on such a large and broad amount of information.
Okay. All right.
And then
go ahead.
Just another piece that I think is important is that a lot of time when we talk about entity resolution, we're thinking about structured data, right? Things that are in tabular form, like an Excel sheet, right? We've got rows, we've got columns of data. But large language models can also handle unstructured data, right? Text data. You think about how you use ChatGPT, you feed it a full sentence, right? And it actually inherits and understands the structure of that sentence to be able to break it down into like a query. Versus any other model would have a really hard time breaking up a sentence or a piece of unstructured information because it hasn't been trained on that, right? It doesn't have the labels and the experience to know the different components of a sentence, what is important, what is the thing it needs to look up, versus a large language model does.
I think the large language models are fantastic. I mean, when you, and not to get us off completely, but when I just say what is entity resolution anyways, and it tells me what it is, and then I'll be like, well, give me a real live example in the pharmaceutical industry, and it does.
Mm-hmm.
Yeah.
Yeah.
I don't know if it's true or not, but it looks like it. So that's the danger, I guess.
Yeah, I mean, certainly one of the dangers is that it's trained to respond back in a way that it sounds certain,
That's
which
right.
makes you trust it more, right?
Exactly. I'm like, I guess I better not put that on there. And so getting to dangers or whatever, how can organizations ensure the ethical use of machine learning and entity resolution, particularly with, respect to issues such as privacy and bias?
Yeah, this is a great question and a loaded question and a packed question. And so I think that first off, like organizations need to do their own due diligence. They need to really understand what is the outcome of this data being used for, right? I think that like I preach this about ethics, but what is the cost of having a good match versus an incorrect match in your environment? Are we talking about we're going to mess up on a marketing campaign, or are we talking about somebody's life could be at stake? This could be healthcare information.
Yeah.
These types of decisions and the impact obviously should influence the degree of transparency and regulatory process that you implement into each step into building one of these models and using one of these models. But in any sense, I think that it's a good practice to measure and understand a bunch of different steps or phases within this process of using machine learning to make decisions for you.
So quick question around that is, and I'm very interested in it's a large language model. It learns on its own. It just gets smarter as it goes. How do you make sure of that? Like it's learning, and how do you stop it from doing that? You know what I mean? Like if it's, well, I don't believe what, I don't know to say I don't believe this, but it's now smarter than us. You know what I mean? Like how do we stop it? Maybe I just don't understand the ins and outs of that stuff, but.
Yeah, I think that, so for large language models specifically, you really need to make a decision on how much you can trust a model to accurately represent the rules and regulation and data stored actors within your organization and how much you want to rely on that. And really that comes back to what is the cost or impact if this model gets something wrong, right?
Okay.
I mean, I think that if you talk about the process, it's making sure that you have clear understanding of your data collection, your labeling, your model development, and you have really good systems in place that monitor and audit these models for bias and privacy violations. And
I feel like there's going to be so many problems at first with these, man. I really think
there will be. There is
huge opportunity.
Already is.
Exactly. I mean, I think it's a great thing. Don't get me wrong, but I think there's just going to be some really interesting challenges. And talking about challenges, let's get back to entity resolution. What are some of the challenges that organizations face when implementing machine learning for entity resolution, and how can these challenges be addressed? It's challenging you big time today.
So let's start off with the one that we just touched upon, which I think is probably the biggest when you're talking about large language models, is interpretability and transparency of models. Can you really understand how a large language model made a decision? Is there traceability? Is it auditable, right? If that is something that matters to how you make decisions with your data, you should be very concerned about using a large language model, right? I think that, if you think about organizations, the other challenges that they really run into are things like, are these models being maintained? Are they updated? Data changes over time, right? These models have to evolve and be retrained to understand the context of your data if it's changing rapidly. Was your model trained on the right data, right? Do you have a really complete view of how you're trying to join two records together or find similarities between two records? We are constantly building models and evaluating information where we have to say as data scientists, okay, there's not enough data here to really make any conclusions. like our data isn't a high enough quality that we can leverage machine learning, nor should we be leveraging rules or anything else because we have bad data.
Yeah.
So, make sure that you're really monitoring the quality of your data and you understand how the quality of your data impacts decisions. And I think if you have that holistic understanding, you should be using machine learning or at least considering it in your process.
Yeah, that was good. What are some best practices for selecting and implementing a machine learning approach to entity resolution? And what are some of the factors you should organizations consider when making some of those decisions?
Yep. So I think the first thing and the first and foremost, most important thing is define clear goals for your model, right? Clear goals and success metrics. What are you trying to do with machine learning and entity resolution? And how is a model going to contribute to that? Assessing the data quality and availability is also really important. And then, right, choosing the right algorithms for the job, right? If this is something that requires transparency, a large language model probably isn't the right approach. If it's something that is going to need more accountability and traceability, maybe a decision tree type model is a better approach because you can actually understand that logic and those weights. If explainability is something that's more important, there's another set of models that would be useful, right? And so really it's trying to make an understanding of what are the goals of and what job are these machine learning models and what job is entity resolution really trying to do for your business.
And these are decisions you're making right now in your current job, right? So, I think this is perfect timing for you
Yeah.
and for us. But how can organizations measure, the effectiveness of their entity resolution efforts, and what metrics should they use to evaluate that success?
Yeah, so that's also really great. I'm a firm believer of having a human in the loop, spot checking the accuracy of your models, right? You can score everything to death, you can create labels to death, but you should also have humans or people evaluating these models. I'm not going to get into all of the technical scores of how you evaluate and kind of understand the quality of a model because I don't think that that would be super useful. But I will say that there's a number of different strategies that we can use to look at scores and kind of back test these models to understand and make sure that they're making the right decisions. But also, it's creating really good lines of feedback, right? Who are the downstream consumers of this data of the entity resolution? And how do they play an impact to updating it if it's incorrect and notifying people, the data stewards or the people who are responsible for running this entity resolution component within a large organization that the decisions have gone awry, right? The data is incorrect. That is a critical piece to any infrastructure and system that really needs to be thoroughly thought through. A good example of this would be you're feeding data into a Salesforce, right? You're taking data from your whole organization and then it's going to Salesforce as prospects, right? Well, if reps are using that data and they find out that it's incorrect, they should have some way to be able to tell you that this data is incorrect because they're going out and they're manually validating that data. They're using it, right?
Yeah.
And that flywheel, we like to call it, is critical to not only making your model smarter, but also keeping the data stewards informed and the people that are consuming that data, arming them with the capability to make the whole process better, right?
Yeah, you mentioned something before. We don't have to get completely into it, but I think it's worth mentioning is the data quality that goes into these models has to be, to me, I mean, especially with the entity resolution in a product company like we're at, really you want to make sure that data quality is very good, I would assume. And are there you can just say yes or no to this, but are there machine learning types things that you could do for data quality to kind of check some of that?
Oh
I mean, I
yeah,
know you're doing
absolutely.
entity resolution and kind of doing some of the matching and things, but just kind of a thought.
Yeah, I mean, absolutely. Monitoring the quality of your data, there's a whole another set of machine learning tools and
Hmm.
models and capabilities that you can leverage to help automate the process of monitoring quality. You think in the average organization, you might have thousands of data sources. And each one of those data sources might contain thousands of attributes, right, to a specific entity. So you're talking about tens of thousands of pieces of information that should be tracked over time and we should be understanding the quality of each one of those. A human or even a team of humans is really going to struggle to do that.
Yeah.
Machine learning can be used to monitor that data over time to understand if the accuracy, the consistency, the reliability all of these data quality metrics, which are useful for you to be able to dive in and understand, am I feeding the model the right information? Is entity resolution happening correctly? But also, what could go wrong? If you have 1,000 sources, it's a matter of time before things break. There's lots of different teams involved, dependencies. You need to have a clear bird's eye view of everything that's going on, and machine learning is one really good way to help amplify that view.
So we've been talking a lot about, the models and machine learning, entity resolution, and so I'm trying to, in my mind, figure out what the hell is he talking about, and how can we put this into real world use case for, of machine learning and entity resolution, and tell me some of those benefits of implementing such a solution. I want a real life experience or a real life thing.
Oh yeah,
put in my head here.
So I mean, a great one that we don't probably talk about enough is like fraud detection, right? When you think about an organization where you're collecting data from websites, mobile apps, all these different locations, you're getting, millions of users registering and using your services. Well, these fraud people who are doing fraud, they're no longer just putting in like the same John Doe, right? Every time they register a new account or create a fraudulent profile, they're using real information, right? And so for the average data steward to be able to spot a fraudulent profile would be really difficult. But what we can do is we can use machine learning to look at probabilistically what's going on within your customer base, right? And if you don't have clean, consistent, high quality data coming from a source like an entity resolution source or a master data management source, then you have just complete chaos because you've got thousands of distraught sources that are trying to make sense of data differently in different silos versus one centralized place where you can look across all your customers and do something like fraud analysis on top of that. Another great example would be, the process of construction, right? When you think of mastering a job of construction, right? Building a building or a large house, how many tens of thousands of pieces of information from different suppliers and vendors and sources are being cobbled together to try to make sense of what's going on? A great use case for entity resolution, where you have to take lots of complex sources, bring them together into one holistic view, and that can give you sense to what's going on with the project, forecasting, supply chain issues, construction workers, employees, mastering all of that together to have a holistic view of a very large, complex job.
Well, that's really good. There's a few more questions, but unfortunately, we're not going to be able to get to them today, Michael. But maybe we should do a part 2 of entity resolution and machine learning. I think that might be a good idea. But Michael, thank you. That was really insightful and helpful.
Absolutely. And if anyone has any questions, don't forget to hit us up on LinkedIn or through email, and we look forward to seeing you all again soon. Thank you.
Yeah, and make sure you rate and review us. We love those. The more we get, the better, and the more we're seen, I think, within all the algorithms of Apple and Spotify and all those other things. But I'm Chris Detzel, and
I'm Michael Burke. Thanks for tuning in.
Coming to another Data Hurdles. Bye-bye.